This is 6.5 conditions for special parallelograms. So everything from 6.4, we'd say like if it's a rhombus, we know these things about it. Well, this one is just the converse. So saying if we know these things about a certain type of parallelogram, then we can know if it's a rhombus. So kind of those rules we learned yesterday, same thing, it just works backwards. So if it does have to be a parallelogram though. So if it's a parallelogram, which this one has the arrows, and they meet at a 90-degree angle in the center, so the diagonals, I guess, bisect at 90 degrees, or the diagonals are perpendicular, something like that, then it's a rhombus. The other rule that said if the diagonal bisects these opposite angles, then it's a rhombus. And then, sorry about that, then the one for rectangles was if it's parallelogram and if we know these diagonals are congruent, then it has to be a rectangle. So I'm just going to write out that big list that we have because that's really the gist of it. So remember, a polygon is a many-sided shape, and then we had like triangles, we had quadrilaterals, we had pentagons, hexagons, heptagons, etc. I don't feel like writing them all out. So polygon is our overarching category. Then we have all, let's not fill that in. Then we had all of these types. But we're going to hone in then on quadrilaterals. So here, I want to make this, I'm going to bring that down a little just so we have. So specifically with quadrilaterals, then we had parallelograms. We are going to learn about other types besides just parallelograms, but not today. So other types would be like a kite or a trapezoid. But we'll do those a different day. So under parallelograms, we had 4 main rules. So the rules were that diagonals are bisected. We had that opposite sides are congruent. We had that opposite angles are congruent. And then the fourth one was that same side interior add to 180. So all of that is true about parallelograms, which is a type of quadrilateral, which is a type of polygon. Then under that, we had rectangles, which is a type of parallelogram, and a rhombus, which is another type of parallelogram. And we had rules for those. And so those rules we learned yesterday, today we're just saying it works both ways. If we know it's a parallelogram and these rules are true, we can say it's a rhombus. If we know it's a rhombus, we can say these rules are true. So it works both ways. So for a rectangle, we had that diagonals are congruent. And then, of course, just the regular definition of a rectangle, which says it has 4 right angles. And then a rhombus, this one says that these opposite angles are bisected. So opposite angles bisect. And it also says that the diagonals meet at a right angle. Oops. Diagonals meet at 90 degrees. And then, of course, this is just the definition of a rhombus. All four sides are congruent. And then for a square, that does not look like a square. There we go. It was all of the things about a rhombus and a rectangle. So square had all of these rules. And all of these rules. So a square is really just a rhombus rectangle. So this is really kind of what I wanted you to see. So today's lesson is just the converse of 6.4. It's saying if it's a parallelogram and this is a right angle, we know it's a rhombus. Yesterday it said if we know it's a rhombus, then we know it's a parallelogram with a right angle. So it's just kind of the reverse. So this is our big old chart about parallelograms, and more specifically then about rectangles, rhombus, and a square. So there you guys go. The homework, there's a lot of ones like this that really want you to explain everything. So I'll start with that one. It's a lot of writing, and then we'll jump into just kind of the math ones. So this one wants you to explain all of the details. So I'm going to take my chart. I'm just going to take this parallelogram part because that is what we're dealing with. And I am going to bring it down so I have it with all my rules. Okay, so this one said, here's the desktop. They told us that AB is the same as CD, and BC is the same as DA, and then they also said this is a right angle, and they want to know why it's a rectangle. So they're basically saying, how do I know from this list that it's a rectangle? So first I have to show that it's a parallelogram. So we would say it is a parallelogram because opposite sides are congruent. So that was rule 2 here. Then in order for it to be a rectangle, we either need the diagonals to be congruent or 4 right angles. So we have 1 right angle, but since it's a parallelogram, since it's a we know that opposite angles have to be congruent. That is rule 3 right there. So we'd have to say angle D is also a right angle because opposite angles are congruent and B is a right angle. I didn't feel like writing right angle out, so I just drew the picture. So they really want us to step it through. So now we know that is a right angle. Then we know angle C is a right angle. And that's because since this one's a right angle, same side interior have to add to 180. So 90 plus 90 is 180. So C is a right angle because of this rule right here. Same side interior angles add to 180. So because in a parallelogram, which we have because we proved it up here, same side interior, add to 180. You could do a full like written out proof 2 columns for this. I just think this might help you guys to explain it a little better. So then we can say angle A is a right angle, and I'm going to copy and paste because opposite angles are congruent. And instead of B being the opposite one this time, C is the opposite one. So it's a lot to prove it. So now we know A, B, C, D must be a rectangle. Because we proved it's a parallelogram with 4 right angles. There you go. It's a lot, but what we did is we found that it was a parallelogram because the opposite sides were the same. Then we knew it was a parallelogram, so that's how we got to show all the different angles. And once we had that, we knew that the 4 angles were right, and that is why we proved it as a rectangle. So obviously, I know you're not going to have to do this in your day-to-day life. The point of it is to get you to think step by step in like a logical kind of manner. This is true, then this is true. If that's true, what's next? It helps develop the logical thinking. So we'll do a couple of the other math ones. This one just wants to know, like, if we know it's a parallelogram, if they're telling us it's a parallelogram, is it a rhombus, rectangle, or square? And this one should be a rectangle. And the reason is just because this is 14 and so is this. So your explanation, you don't have to write it all out, but you would say diagonals are congruent. They are both 14. And if you already know it's a parallelogram, this one would have to be a rhombus because it meets at 90 degrees. So you just go from your list and be like, is it one from here or is it one from here? And then this last one, I think they made a typo. It should say rhombus, not square, because rhombus is the one that has the diagonals meeting at 90 degrees. And even though a square does as well, they didn't say anything about it being basically that it had right angles in the corner. They didn't tell us that. So this should say rhombus. Anyway, this is a basic math one. They want you to know that should be 90. So they just want you to solve for x. So this part isn't as difficult as all of the explaining. And I don't know that in my head. I think it's 14. Yeah, I think it's 14. So, but most of your homework is honestly going to be like this, where you have to really write it out and explain. They really want to develop that logical thinking. So here is your homework, 6.5.